avoid contact, 100% keen and modulation is go. 4, 3, 2, 1.
Hi everyone, I'm Philipp. It's not that dystopian. We'll be very much in the reality and see what can actually go wrong and is dangerous in the world. So, Perils of the Cloud, as we've already said, I organize some meetups, so if you come to Vienna at some point, I'm happy to have you there. I run one meetup about databases in general, like relational, non-relational, anything about databases, and the other one more on the academic side. So, previously, maybe at university, you were forced to read papers. We kind of do it, on our own. We read a paper and discuss it. And I work for Elastic, the company behind Elasticsearch, Logstash, Kibana, Beats. I'm part of our infrastructure team, and we do stuff like AWS, Docker images, Jenkins testing, automation with, Ansible, Chef, Puppet, whatever. And I always say that in the middle is a Unix pipe. I kind of piped that out into developer advocacy. So today I'm kind of telling you both what we are doing at Elastic, but also at my previous company to kind of protect our cloud setups from bad stuff. So just to get an idea, who's using something in the cloud already? Azure, AWS, Google, few, that is, okay, a few. Does the cloud solve all your security problems? Yeah, unfortunately, I'm not so sure about that one. It's a different set of problems you're getting. It's pretty much with every technology, you have like one set of problems, you switch technology, you get a new set of problems. And maybe this is a better set of problems or a worse one. So we will see how bad it can get. But some people are betting very big on the cloud. So Adrian Cockcroft, he was the guy who made Netflix what Netflix is today. Because at first, Netflix was sending out physical DVDs to people. And then he was the guy who kind of started them to have this massive video platform where you can see and stream everything online. And he's now working for AWS as well. So yes, he's of course saying nice things about them, but that was before he joined them. And yeah. Some people have come to the conclusion that it's probably more secure to run on AWS than on their own infrastructure because AWS has countless security experts who are just working around security. And probably if you want to host everything yourself and provide all the services yourself, your infrastructure doesn't have all the people to do that for you. And yes, there are security issues around AWS or whatever your provider is. Like Xen, when you can break out of your virtual machines. Heartbleed, of course, affected them as well, since, thanks to OpenSSL. But we're not going to talk about that. What is the main problem that most people face when they do something in the cloud and something goes wrong? Unfortunately, that's mostly us. So let's talk more about the stuff that we do. Or let's see first what can go wrong. Code spaces. Probably nobody has heard of code spaces. They were a bit like GitHub or SourceForge or something like that. You could store your source code there and your artifacts. And yeah, they're gone. They stopped in 2014. They were hosted on AWS, but something bad happened. Like that is kind of the last message they had on their website. Like they had everything in their AWS account. And somebody got in there and partially or completely deleted everything. And it was kind of like somebody got a hold of their credentials and tried to blackmail them, and they didn't want to pay up, and they tried to lock out the attacker, and he then kind of just nuked everything. So he just like deleted their instances, deleted the backups, like everything was in that one single account, and it was just gone. And like you had stored your issues, your source code, your artifacts, everything there, and it was gone. And that was pretty much your end. So yeah. That didn't work well. Then there was DrawQuest, which was some community game which people were playing. There again, somebody managed to get a hold of their security token somehow and started to mine Bitcoins. which on AWS doesn't make any sense because you probably need to invest $1,000 in AWS bills to get like $50 of Bitcoin worth out of that. But if it's not your money, you can still do it. And that is something that many people are trying to do. They will just start mining some cryptocurrency, especially now. Bitcoin is currently super high, like 2,000 or more dollars. So people will start mining Bitcoins if they can somewhere. And it can get very expensive. Oh yeah, that game went out of, like, it was not a business. They didn't have the resources to clean it up, so they just shut down at that point as well. And then there was Bonsai. They're still around. Incidentally, they provide Elasticsearch as a service. And they had even a nicer outage. They went to bed, and when they woke up again, their infrastructure was gone. And that was pretty much like somebody who didn't like them or was a competitor, like it was not us. Don't get the wrong idea. But somebody got their credentials and just terminated everything at night. So like they had all their instances running with Elasticsearch instances, and somebody just terminated all the instances, and when they woke up in the morning, everything was gone. And it took them 24 to 48 hours to restore everything. Luckily, they had some snapshots, and their snapshots were not deleted. But it was probably not a great day for them. And how that happened for them is they documented it. Like they said, like somebody wrote an internal tool and committed their AWS credentials into that tool. And they were sitting there idly, and sometime later, somebody else decided, well, this is a very nice tool. We could open source that. Just show everybody how cool we are. And yeah, somebody then just started scanning GitHub, found the credentials, and didn't like them. Or maybe somebody was looking for that already, and then everything was gone. Yeah, so don't do that. Yeah, somebody got their API key, and that was pretty much that. Yes, you probably need a drink after that. Like, maybe the cloud is not that great idea after all. Maybe you should host everything on your own service, because while it's super easy to spin up everything very quickly on the cloud, it's also super easy to destroy everything again. So it's kind of a trade-off. It's both quick to create and both quick to destroy. But we'll just take a look at what you can do, like 101 easy steps. I hope the timing works out. How to secure your account. So, first off, about accounts. On AWS, you get a root account. And the number one error people do is that they start off with that root account. What you should do is, you should create other accounts with your root account and then lock your root account away. Like at my previous company, the credentials to the root account are in a safe, and nobody has that password on their laptop. Like, you physically need to go to that safe, get the password out, otherwise there is no way to get that. The problem is there are no limitations whatsoever to the root account, so if anybody gets a hold of that, it's over. So don't go there. You should use, it's called IAM, Identity and Access Management, where you can actually create credentials and see how they are going. And yes, AWS has lots and lots of services and lots of weird acronyms, though IAM is super easy to remember, because that is kind of my mental bridge of how to know what IAM actually means. Yeah, that's kind of the point. Like, I am what I am, so that is what IAM is, and you should always use IAM. So generally, it is strongly, or I would strongly encourage to have like one access set per service, person, or action. So if something gets compromised, you can very easily rotate that. Or something you can also do by now is that you can actually delegate permissions. So you don't need to bake in any credentials or use any explicit credentials, but you can actually say, like, this EC2 instance, for example, can access this S3 bucket. And it's kind of handled in the background by AWS, and you don't even need to set credentials explicitly anymore. The second thing is control access. It is very obvious, but a lot of people are doing it wrong still. Only allow what you really need. It's kind of the obvious thing, like principle of the least access. So what you can do is, at my previous company, that is what we always said. Like, even I was kind of the main ops person, but even my account couldn't do some stuff, because some stuff is just plain dangerous, and there are very few instances where you need to do those. So for us, that was release address, which is like you can get static IP addresses, and we had like customers, and they had configured those IP addresses on their firewalls. So if we lost those IP addresses, it would be a major hassle to reset everything of that. So while I could create new static IP addresses, I could not release them. And releasing basically means putting them back into the pool AWS has, and somebody else can then get that IP address. And there's very little chance that you will ever get that IP address back. So even my account, even though I was kind of the main admin, I could not release IP addresses like that. Or for hosted zones, for DNS, there are very few instances where you want to delete a hosted zone, like the entire domain. Yes, you need to clean out all the records in there, but you can still delete that, and it will not be a great day if that happens. So I just didn't have the permission to do that. So yeah, just hand out the permissions you really need. Use groups, like don't attach permissions to every single user, because it's going to be a nightmare as soon as you have more than 5. And only give the permissions that you really need. So for example, S3, the storage where you can store data, if you have your backups, that is maybe not even the right permission. So what I can do is, I can to com example, backup, whatever, I can store data with put, I can read data with get, and I can delete them. If those are backups, probably you should skip the delete option, because like, yes, your service can store stuff, but maybe you don't want the service to delete its own backups again. Because if that account is compromised, all your backups are pretty much worthless. So you might have like another service account to clean up after some time, but you probably don't want to be able to delete all your credentials right away. And the other thing that is very important is, there should be very few people who can actually give out IAM permissions. Because if somebody breaks into your system and they get an account with IAM permissions, they can create more users, or they can attach new keys to existing users, which is even worse, because then you will just see like, oh yeah, that person is working for the company, that is all fine, that is his or her account. But if somebody attaches more keys, then you need to go to everybody in the company and make sure like, are these all your keys, or did somebody else create it in your account? So the fewer people who can actually hand out these IAM permissions, the less problem, or the fewer problems you will have in the long run, because nobody can actually run that then for you. The other thing is authentication. Yes, of course, strong authentications. Use good passwords. Everybody probably knows that, the battery horse staple, how you can generate secure passwords. I'm still leaning more towards the direction that you should use a proper password manager to generate it and store it. Like, there should not be any reason to know all these passwords in your head. Just store them and be done with that. And the other thing is multi-user or multi-factor authentication, or two-factor authentication, whatever you call it. We pretty much enforce it that you have enabled that on all your accounts. So even if somebody steals your credentials, if they don't have your phone with those tokens, they cannot do anything with that. And the login pretty much looks like that then. So you need to provide like, this is your account, this is your user, this is your password, and this is your multi-factor authentication code. And without that code, you cannot log in. What happens if you break your device? At my previous company, we managed to do that. It was not me. So we had multi-factor authentication set up for our root account. And our CTO had that on his mobile phone, that code. And he kind of factory reset his phone at some point because something happened. And then we couldn't log into that account anymore. And to make stuff worse, like, you always have these backup questions, but we saw them pretty much as a security risk, because it's often like, what is your mother's maiden name, or where were you born? And that is often much easier to guess than your actual password. So we thought we were very clever, and we just put in random strings into these questions. And we didn't store the random strings. And that turned out to be very interesting, because we had a named support contract, and kind of they knew us, and they knew that we had the same telephone numbers and email addresses for over a year. And we said like, hey, yeah, we need to reset that root account, because, yeah, we lost the credentials and we also lost the security questions. And unfortunately, that was surprisingly hard because they just would not do it. You need to have a notary form signed that this is you, the company, and your account, and only then will they reset that. But because their accounting department is in Luxembourg, they can only provide that in English. And Austrian notaries can only do stuff in German. And then you need official translations, and it is a very lengthy and also expensive process. So I would not try to go there. We eventually managed to recover our two-factor authentication credentials, and we changed a few things afterwards. The first one is we bought like a hardware MFA device and put that into a safe as well. So nobody has it on their phone anymore, but it's a hardware device. And the other thing is we also reset these security questions. And what we then did is, I think it's 3 questions, and we basically split that up. So one person in the company only has the answer to one of the questions and has that in their password manager. So you would need would need to get into the password manager of all 3 people who have those to get them back. And kind of when I left the previous company, I kind of handed it over to somebody else. It's kind of like a physical token you hand over. And somebody's carrying that around. And by that, even if the MFA device breaks for some reason, if the 3 people combine their answers, you can actually regain access. And it's kind of, yeah, high-grade security already. Yeah. Use hardware tokens and store the fallback questions. Otherwise, yeah, you're stuck. Code. That is actually very simple. Never commit your credentials in the clear. And I could say it like 10 more times, but I hope you get the point. Because the bad guys are not stupid. They're just starting to scan GitHub, and they're not only like scanning actual repositories, but they're also scanning like the commit events. So even if you find out you have committed something and you see, oh, that was bad, and you rebase your account to get that commit out, it was pushed out in the commit message, or in one commit actually, and the bad guys are actually scanning those. On the other hand, AWS and GitHub and others are also scanning GitHub and other providers and try to find their tokens there, and then will block those tokens automatically. And then it's just a race, like who is quicker to find your tokens. But I would not really want to rely on who is quicker to scan GitHub to find tokens. So don't do that. The other thing is network. One really nice feature about accounts on AWS is that you can enable IP restrictions. And that looks something like that. So if you have a VPN or your company has an IP address, you can add that. And you can say, when you log in, everything is allowed, unless everything is denied if you're not coming from these IP addresses. And that kind of makes a lot of sense, because why should somebody from China be able to log into your AWS account? So we basically whitelisted our VPN and our Office network, and even if I gave you my credentials and my two-factor authentication code, if you didn't also come from the right IP address, you still could not log into that. So that is just one more layer of security that we added there. So even in the cloud, while you cannot like have the big firewall in front of everything, many providers provide the tools to actually have that kind of virtual firewall in front of everything. And the only confusing thing is you can still log in, but then everything will be denied. Like you cannot really see it, but it says like you're not authorized to do something a lot of times. So while you can log in from another IP address, you're actually not allowed to do anything. Because the AWS console is pretty much like the API. This is just a front end put in front of the API, and it's just like querying the API, and the API is telling you you're not allowed to do that. So while yes, you can log in, you cannot do anything if you're coming from the wrong IP address. Tools. One clever thing is to enable billing alerts, because the bad guys are normally not stupid. If they want to mine Bitcoins, they will get your tokens, and then they will wait for like the 1st to 2nd of the following month, because you will get your bill at some point, and you see everything was good. And then they have like a full month to start instances to mine Bitcoins, and you don't really see it if they start at the beginning of the month. But if you have billing alerts, like I normally set them up like in the middle of the month to see like if you're there, probably you have configured something wrong and didn't stop some instances that you should have stopped. But if somebody's breaking in and starts to mine Bitcoins, you will very easily or early see that you have like breached half of what you should hit. And I also had an alert at the end of the month, and I knew like when we were above that, that is pretty much what we plan to spend. And if we got above that very early, it was not a good sign. And yeah, billing alerts will look something like that. So that was from my previous company at Elastic. We have like, our bill is slightly higher than $2,000 a month, but just slightly. But that was what the billing alert looked like. Like that we were expecting to pay about $2,000 a month, and we got that. And if it wasn't at the end of the month, we knew something was very off. Enable CloudTrail, which is very nice. Like all the AWS events you can have can be put into an S3 bucket. And then you can just review what is going on. Because if somebody breaks into your account, the first problem is often figuring out like what is actually going on, like which account was breached, like who is doing all the bad actions. And that is something that you would get. And there you can see that the user Alice with the example key ID stopped the instance with ID I something something. That would be stored in S3, and then you can actually see which account is terminating instances or starting new instances to mine Bitcoins. So that is actually very helpful. And I would generally also recommend don't store that in your own account, because if somebody breaks into your account, they could just delete that data. So store it into an external system. And well, at Elastic, we're all about dog fooding, or my French colleagues would always say, drink your own champagne, because they don't like dog food. We put all that data into Elasticsearch running in another account, and there we can very easily search it. So we're using internally, we're heavy users of our stuff internally. Just all the events we have in AWS on our infrastructure team, we put like, Logstash is pulling it out of S3, parsing it, storing it in Elasticsearch, and then in Kibana you can visualize it, and you can just search for an instance ID, an IP address, the actions of a user, termination notifications, anything. Like you can just search that through Kibana, and that is very convenient. There's a security status that is kind of like, if you don't want to invest too much energy, it will just like show you, did you do everything right with your account? Like, have you rotated your keys recently? Are you using the IAM user, or are you using a root user? And it's just like, if these are not green, you probably should check them. Then there's premium support, which, at least in my experience, premium support really pays off. Like, otherwise you're stuck on the public forum, and you can always pray that somebody will help you or not, even though it adds quite a few % to your bill. And they also have this advisory. Again, that is a screenshot from my previous company, and it will just tell you, like, you can optimize costs, but it will also tell you stuff about security. And you can really dive into that and see, okay, you have like ports open, or you have very permissive rules on IAM users. It will just tell you about those, and you can then go in and fix that, or whatever makes sense. But it's just a nice way to see what is going on. Custom tools. We have built something, an AWS Lambda, since everything is on AWS, that posts a message to our Slack channel to actually tell us every time somebody starts an instance in our account. Because otherwise, all the engineers and support people and solution architects and everything, everybody has access to our AWS account, and everybody can spin up whatever they want. And somebody does bad automation or something, so we want to track that. And that is very convenient. So an S3 Lambda is just listening for events of the AWS API. And every 5 minutes, it will post those statistics like who posted or who created what kind of instance. And that is being posted in there. And our infrastructure team, that is mostly for testing and downloads and stuff. But we also have a cloud service, and they have their own AWS account. So that's nicely separated. And once this really happened, is that Buzz, one of our cloud colleagues, actually started this R3 large instance on kind of the general account. And our team lead said, kind of jokingly, go back to your own cloud, so basically your own AWS account. And actually, it turned out that was a case of bad automation, and nobody would have noticed. Like, he would have started a bunch of instances and had them running in our account, and would not have found them anymore. And yeah, it's getting quite expensive if you have lots of large instances running that nobody knows about. So yeah, he was just using the wrong credentials, and so that already proved to be very valuable for us. And we have a bunch of lambdas who actually do stuff. So every time you start an instance, there is a lambda that will tag the instance with the user that created that one, so we can very easily see it afterwards. Or we have something called a cost explorer, which will generate all the costs, and we're internally, also in Elasticsearch then, have stored all the costs, and we know the costs per user. So we know who is causing how much AWS cost. And if somebody has a very large bill, we'll probably ask, like, what are you actually doing? Do you really need all those instances? Yeah, attacks. Let's see it both from the attacking and the defending side. If you want to make money, get some credentials. And the best way to actually go then is add keys to existing users, so it's much harder to figure out what is going on, and then start instances in regions that that account is not using. So you can use Japan or Singapore or some obscure region nobody ever checks in the AWS console, and probably you can start mining Bitcoins there for quite some days or even weeks without anybody noticing. So if you want to make money, that is the right approach to do that. If you want to destroy your competition, one of my colleagues once, I think he even created a script, but he never ran that, but he kind of made the ultimate destruction script. So that script would just go into an AWS account and really destroy everything. And you need to pay attention to the right order. So the first thing you should kill is the AWS lambdas, because somebody might have some jobs running there to check stuff. So you disable that. Then you disable the notifications, SNS, the notification service. So if there are any internal notifications, nobody sees those. Then you go into S3 and delete all the buckets and get rid of the data. And only then do you start to actually terminate the instances and the databases. So make sure all the backups and everything is gone first, and then you can delete the rest. That is the right approach to destroy your competition. If you want to defend yourself, the first step is don't panic. And don't delete the evidence that you have there. Because AWS can be very forthcoming. Like, there are instances where they actually, just like you have a huge bill like 50K because somebody started mining Bitcoins, and they might not charge you for that actually. If you can prove that somebody broke into your account and you're a first-time offender, then you're just like, oh, sorry, we were stupid. And if you're a good customer in general, they probably will waive that big charge for you. I know that happened to quite some companies already. But you need to kind of prove that you didn't do some bad automation, or that, I don't know, you were doing something very bad or stupid. So just leave the evidence there and make sure you can prove afterwards what actually happened. So if somebody pushed the tokens to GitHub, leave it there, just deactivate the token. Don't delete it, deactivate it. And then just deactivate all the other tokens that person has created. Stop the instances, but don't delete anything. Just leave the instances there which have been mining Bitcoins, so that you can actually prove, oh, look, somebody was starting instances in a region we were not using, and they used these big instances and started mining Bitcoins. So you can really prove that it was not you doing something stupid, but it was somebody breaking into your account and causing that massive cost. So generally, what should you do and what should you not do? If a key is compromised, rotate it. Because there are always these people like, yeah, we'll just rebase the account, it's super quick, like nobody has noticed, but probably somebody has just listened to your commits and has that key by now. And there were instances where people actually did exactly that. Somebody got their key, they thought they just rebased it out, but then somebody found the key, had already the keys, and it was too late. So key rotation should be easy in general. Store your credentials properly. Like generally, I would say you have three options. The first one is use environment variables and just deploy them. The problem is, how does your deployment tool know how to get these credentials? Then you can use either encrypted files in your source code management or use some of the vaults. I was using the store encrypted stuff in your source code SCM. There is a very nice blog post by eJohn. Does anybody know who eJohn is? Some random unknown guy. Yeah, he did that one. That's John Riesig. The creator of jQuery, he is now working for the Khan Academy, and he has this nice blog post where he describes their workflow because they say it's super simple. They say like environment variables were, yeah, but I still have time. I have 15, yeah. Wow, okay. You will have time for questions, don't worry. So they said like environment variables are a pain in the ass to set up for them because every time you have a new developer, they need to set up all the right variables on their laptop and it's very hard to share them. So they just have everything in an encrypted file, which they push, and then you just decrypt that locally, and you can only push the encrypted file. So he used some script like that. That was the version I was using. So pretty much you have like, you just have a file and you encrypt it to get and add the file extension AES-256. And to decrypt it, you just decrypt it and store it without the extension. And then you put into your git ignore the plaintext file so you cannot accidentally commit it. So yeah, I was using AES-256 CBC, which is widely available if you're a crypto freak. Like there are something is wrong with that. Like there could be minor problems with that, but generally this is like widely available in lots of OpenSSL versions. So this is a good one to use. And how to use that? So we were using Java and we were using JKS trust stores. And we basically just committed the trust store jks.as256. You run that one shell script. It will give you the decrypted file, and you can always encrypt that, and you can already push that encrypted file. So that is a very nice setup to have some files with variables, with passwords, or some certificates. Or you can use some of the vaults, like there's HashiCorp Vault, which has a lot of fancy features. We're using that at Elastic, and just 2 days ago we shut it down because we didn't properly monitor, which is kind of embarrassing for us, but yeah. So it is I think it was kind of, again, the perfect storm what you always have. It's like at least 2 things break and then everything is broken. And we had something like we have a high availability setup, so we have 3 nodes. And the one node that was the active master, handing out the secrets, that disk filled up and we didn't monitor the disk space. And the problem then was with the disk that was full, it couldn't renew its Let's Encrypt certificates. So we were using Let's Encrypt for the certificates, but it couldn't store the new certificates because the disk was full. So at some point, our certificate just timed out because Let's Encrypt certificates are pretty short-lived, and then nobody could log in anymore. And then we ran into a vault bug that the failover was for some reason not working correctly. So it's always a combination of multiple things, but yeah, if you're using Vault, it's a very nice system and it's decentralized, but you need to really make sure that it's up and running, otherwise everything will stop pretty much immediately. Ansible Vault is kind of the less effort thingy. It's pretty much in your deployment process, you can just say like, every time you deploy that, there is this file that is encrypted, just decrypt it and get the credentials out and use them in your script. And then you can commit that to GitHub and everything is in that one encrypted file. You just have one password everybody needs to know to decrypt that file. But that is kind of the simpler approach. You don't have a distributed system that you need to make sure that stays up and running. You just need to decrypt that file every now and then. But Ansible manages that in the background for you. You can also check your code. Like there is GitRob and Git secrets that can scan your GitHub projects for secrets. I tried GitRob once. It's a Ruby application. It's a bit finicky to get up and running. The problem is it is only working on file names. So it's just checking, do you have something that looks like a certificate? So if you have a PEM or DARE or whatever file extension, it will alert you. Sometimes we have like for tests, dummy certificates. So A, it didn't find the tokens in files we had. And B, we had a lot of false positives because we were just using dummy files for testing. So we didn't really use that. We tried it, but we gave up at some point. Maybe the Git secrets is a better thing that checks every time you commit. Before you commit, it actually checks that commit if there is an AWS secret in there, since it's from AWS Labs. So that might be the saner choice to check all your commits and make sure nobody commits any secrets. To conclude, there is no magic. Like, for that talk, I sometimes get the complaint like, okay, but where's the magic? Like, how do I fix everything? Unfortunately, there is no real magic. It's just pretty much about housekeeping. It's just like, do the right thing and don't screw up. And You don't need any magic because like so many people are doing way worse than you. And attackers are mostly like pretty lazy. They will just go for the easy targets. So as long as you're doing better than most of the others, unless you're a super high profile company, you're probably doing fine. I'm not saying security is not important, but it's like, if you're better than the others, you're probably doing already very well. Yeah, and just like 2 more cases where somebody did the obvious stuff wrong just to get the message across. Somebody has 140 servers running, though they were only using S3. They had it in GitHub, but only for 5 minutes. And there are already 2 main or cardinal sins. Like the first one, if your key is out there, rotate it, because even if it's just 5 minutes, somebody can scan within those 5 minutes and get your credentials. It's fully automated, no human interaction needed. And the other thing is, if you just need S3, why can you even start EC2 instances? It's just totally unnecessary, and it's bound to make your life worse than it has to be. And then somebody who seems to be very experienced, but he still committed credentials. And the problem was there was a bug in Visual Studio in some specific version where you thought you created a private repository, but it was actually public. But yeah, it is a bug in Visual Studio, no question. But you still, even if it's a private repository, don't commit your stupid credentials. It's just no way around it. You will suffer for that. And I'm not sure if he got his money back, but yeah, you can get quite a bill very quickly. And I think that attacker was also clever, like they created multiple IAM users then or added more credentials, and he killed the bit mining instances at first, but then overnight they came back. So you really need to purge your system pretty much. As soon as somebody is in and can create more IAM tokens, you're pretty much screwed. You will need to reset pretty much everything or verify every single key pretty much, like if it's not compromised. Yeah. So the cloud is not only solving your problems, sometimes it's just making your life harder. I still think the cloud is a great thing, but you kind of need to pay attention to the right stuff. Otherwise, you will end up on Bob's boobs and like in 7. Any questions? We still have 5 minutes or so.
Yeah, I guess we have 5 or 7 minutes. So if there are any questions, I run around with the microphone. Anybody?
By the way, I have stickers as well. I will get out my stickers. If anybody wants elastic stickers, I have you covered. Any questions?
Raise your hand if you have questions.
Well, let me start with a question. Did anybody already get compromised on AWS, Azure, or something like that? One. That is a good story. We can talk afterwards. I would be interested in that one. Was it anything that I talked about? Yes. Okay, good. Then I'm kind of doing my job.
Well, then.
Any more questions or remarks or stories to share?
Well, I have a story to share. We were actually so secret about our DevOne credentials that nobody from the team has it anymore, and we weren't able to update the DevOne Twitter wall yesterday. So I guess that's safe. Somebody was still logged in, so this was good. But other than that, well, if there aren't any questions, I say thank you, Philipp. Round of applause.
Thank you.